Hello everyone, welcome to today's presentation on counting the number of possible triangles from array elements. In this presentation, we will explore a fascinating problem and its solution, focusing on the triangle inequality theorem. Let's dive in. Our task is to find the number of possible triangles that can be formed from the elements of an integer array. For three elements to form a triangle, they must satisfy the triangle inequality theorem. This theorem states that the sum of any two sides of a triangle must be greater than the third side. Now let's see how we can apply this concept in our problem. The triangle inequality theorem is fundamental to determining whether three sides can form a valid triangle. To form a triangle with sides A, B and C, the following conditions must hold. A plus B is greater than C, or B plus C is greater than A, or C plus A is greater than B. These conditions ensure that the three sides can create a valid triangle. Let's start with an example. Consider the input array containing the elements 4, 6, 3 and 7. The valid triangles we can form are 3, 4, 6, 4, 6, 7 and 3, 6, 7. However, 3, 4, 7 does not form a valid triangle because 3 plus 4 is not greater than 7. So in this case, the valid output is 3 valid triangles. Now let's consider a different example. Here the input array is 10, 21, 22, 100, 101, 200, 300. The valid triangles we can form are 10, 21, 22, 21, 100 and 101, 22, 100, 101, 10, 100, 101, 100, 101, 200 and 100, 200, 300. In total, we can form 6 triangles. Let's look at an example where no triangles can be formed. If we input the array 1, 2, 3, it's impossible to form a triangle. This is because no combination of the elements satisfies the triangle inequality theorem. So the output is 0 valid pairs. To solve this problem, we follow a systematic approach. Sort the array. Sorting helps to simplify the process of checking the triangle inequality conditions. Iterate over all triplets. We examine every possible combination of three elements. Check the triangle inequality. For each triplet, we check if the sum of any two sides is greater than the third side. If this condition is satisfied, we count it as a valid triangle. Here's the implementation of the solution in C++. First, we define the function countTriangles, which takes the array as input. We begin by sorting the array to simplify the checks. Then we initialize a variable to keep track of the number of valid triangles. Next, we use three nested loops to check all possible triplets. For each triplet, we check if the sum of the first two sides is greater than the third side. If it is, we increment the count. Finally, we return the count of valid triangles. Let's break down the code logic. After the sorting, we loop through the array using three indices I, j, k to represent the three sides. If the sum of the first two sides is greater than the third side, we know that the triplet forms a valid triangle. So we increment the count. This process continues for all possible triplets. The time complexity of this solution is n cube due to the three nested loops. Sorting the array takes n log n time. While this approach works, there is room for optimization, especially for larger data sets. Techniques such as binary search would potentially reduce the complexity. In conclusion, we have learned how to determine the number of valid triangles that can be formed from the elements of an array. We also explored the triangle inequality theorem and how it can be applied to solve this problem. Although our current approach is cubic in complexity, we can optimize it further for larger inputs. That concludes the main part of our presentation. Thank you for your attention. Now I would be happy to answer any questions you may have. Feel free to ask.